Now, last week we stopped here, right? I remember I showed you this diagram, this PowerPoint. But there's something I want to just update you a little bit. Last week I was saying about the USB port. I can see there are 4 USB ports. This, if you don't know what is this, this is a router. This is the back end of a router. Now, different router has different interface and so on. Now, this is a 1941 router. 1941 router is a very common router lah. Okay, Cisco, in fact, in IT also, our PowerPoints are all mostly on 1941 router. So this back of the panel is actually the back of the router for 1941. So that could be different. Even the port, the lighting is all different. Okay, like for example, we are talking about at this part this part here. Okay, this part here. I was talking about the link, right? The link, you have 2 link. You have this is a 00 link. This is a 00 link, a GE00. This is GE01, GigaNet 0001. Now, then last week we talked about when the link is green. I think very likely is green. When the link, the speed, there's a speed here. When the speed here blink one time, it means, and then it pause for a while, blink one time, pause for a while. Of course, first of all, the link must be green. This must be green. If it's not green, then the speed will not blink. So the link is green, it shows that it's active. Okay. So the speed of GE00 and GE01, if it's one blink, that when the SLED one blink means 10 megabits per second. I think last week Justin Go will say, oh, one blink is 10, 2 blink 20. Very clever. It's very good way to remember. One blink you take it as 10 megabits per second. 2 blink is 2 blink 20, so 100 megabits per second. 3 blink 30, 1000 megabits per second. And this question came out in the exam. I tell you first, okay. Quite some time ago, it came out in the exam. So you don't know what kind of question will come out, and it come out this question. So all right, you might have to remember. And then we also talk about the console. Last week we talked about the console, right? This part is the console. I make a mistake here about concerning the USB part. Okay, now you can see there's a USB Type B here. Now when I look at this panel is actually, you can see the blue color below. There's a light blue now. Can you see the light blue below? The light blue shows that the whole thing is a console connection. So either you use the RJ45, the RJ45 to connect. The console cable to connect to the console. Not the RJ45, the console cable. Later on, you see the console cable is blue color one. Okay, all right. This is a console cable. This console cable is actually connected to this. Okay. So you can see there are 2 console cables now. Either you use the console cable or you use the Type B. There are 2 types here now. If this is not available, then you can use the Type B one. Okay, all right. And then you have the USB here. The USB normally for you to for some people plug in the USB and then you can actually access your USB as a data, become a data source. So you connect back to your router again, you can access your data inside this USB. If you look at your router at home, there are some USB connections. You all never notice. You have a router at home, you look at your router very carefully. Very likely there are 2 USB ports. You plug in a USB port and then you go to the router. But you must configure. You plug in a USB port into a USB and then you go to the router to configure that. Okay, these 2 ports or you can actually access the port like data like that. When you're doing remote, you can actually remote back into your router and then you can access your data in the USB port. So it can be configured. Yeah, your home router also has the same thing. So okay, so I'll come back to the blue console again. Your console 2 and 3, the blue color one. This one, okay, this one, okay, is your console. This is the one. And for you to connect to connect to the router for you to do configuration. This is for configuration. Okay, yeah. Okay, let me move up here. So I was saying just now, the 2 console port. You can see the 2 console port, the blue color one. This one, this one is actually your console port on top, which is on top here. which is on top here. This one, yeah. So this is the console wire, yeah. If you have not seen the console wire, the actual console wire look like that. One end connect to the serial port of your computer, the other end connect to the console port of your router. Okay, so the moment you connect, you can use in reality, of course, in reality you must use the software, the program software called PuTTY or Teraterm. This tool is for you to connect directly to the router for you to do configuration. Then they ask you what is the software that you use to connect to the router to do configuration. The answer is Teraterm and PuTTY. But you have not been doing this, right? You guys have been using your packet tracer. You know, the moment you plug in using a simulation or logical, you drag in the wire, you click on the router, then you can see your CLI already, isn't it? Right? But in reality, it's not like that one. Okay, you need the Teraterm and the PuTTY if you really need to connect to the router. I'll be showing you a router. Everybody touch a real router and connect to a real router using a Teraterm and a PuTTY to do configuration. Okay, so you'll just look at that later on. Yeah, and probably close to the end where you can actually play with the router. So okay, I was telling you your console wire. This console port is for your console wire, and then the other USB. If you don't have the console wire, you can actually use a Type B to connect to the router using the Type B cable, USB Type B cable. This one is from your computer. Yeah. Okay. Now, just in case, go back to this again. Just in case you don't have a serial port, sometimes they don't. Sometimes don't have this. Serial port. So what do? You can actually connect USB to RS. You can actually use an adapter. Can you see you use the adapter? Yeah. Okay. Yeah. USB to RS232 serial port. You can use an adapter also to connect to the console. Yeah. Okay. Any questions? The reason you use this cable is because sometimes you don't have the serial port, so you have a USB port, right? So you connect one end to the USB, and then the other end you can connect to the console wire. Yeah, just to make it clearer. Now this part is your USB. Okay. And then this one you connect to a computer, and then this end you just connect to this, and then this, of course, this one will connect to the port here. Oh, is it clear? Yeah. Move on. I have done this already. I've done this with Vue. But there's one part you need to let me go through this, okay? Now, let me read to you first. Network devices require IP addresses in order for network administrator to connect. We all know, right? Whether you're talking about a router, whether you're talking about even a switch, and then you want to connect to a switch remotely, you also need IP address. And of course, computer need IP address, right? So now you can connect to all these devices using Telnet, or you can use SSH, okay? We have done this before last week. We actually did the lab work on SSH and Telnet, isn't it, right? But I was telling you Telnet not secure because if you use a software called Wireshark, the moment you turn on Wireshark can actually monitor all the network traffic in your computer. So if you have a Telnet connect using your computer to connect using Telnet, you will see that anything that you pass on to the network, the data are actually all not encrypted. You can see all the data on the Wireshark itself. Plain text, you can see them. But when you're using SSH, your data on your network is actually encrypted. So hacker don't know what you're doing. Okay. When your data is passing through your network, your hacker doesn't know what you're doing. Why? Because SSH encrypt all your data that's passing through this network. So your Wireshark, in case they ask you what do you use to monitor your network, one of the software you can use to monitor your network is the Wireshark. Wireshark can see the network traffic that is moving in and out of your computer. Yeah. Okay, that is the first part. Second part. A switch require an IP address. I told you now. Actually, switch doesn't require IP address. Okay. A switch, the moment you plug in a switch will work. But a switch will only require an IP address for two things. Number one, you want to create you want to remotely connect to your switch. Let's say, for example, you have to do configuration to a switch, but your switch is very far away, right? You wouldn't want to go to a few blocks of to the switch and then you do configuration, then you could walk back again. But if you have an IP address on your switch, and then your switch is actually configured with a VLAN, you can actually put in an IP address to the switch using a VLAN, and then you can connect to the switch to do configuration. If not, a switch by itself doesn't need any IP address. But last week I talked about last week during the lab, during a lab, I think on Tuesday. Now I was telling you about the virtual interface, isn't it? The VLAN, right? Okay. VLAN, your switch can actually have VLAN. You can have 4,000 over. You can have 4,000 over VLAN on the switch. You can configure 4,000, but we all know we cannot. You don't need 4,000 over VLAN. Okay, wasting our time. Connect and configure and configure. You don't need so many VLAN. Okay, but you can have 4,000 over. But what are the VLAN for? VLAN is for you to create a segment of the network. Sometimes you want to divide your network for different purpose, right? For example, in your network, instead of having so many router to create different IP addresses, you can actually use a VLAN. Divide your VLAN into VLAN 2, VLAN 3, VLAN 4. VLAN 2 meant for operation, VLAN 3 meant for admin, VLAN 4 meant for financial, VLAN 5 meant for maintenance. Okay, so different VLAN create a different IP addresses and different network for different purposes. Now that's the way of using VLAN. So the moment you use VLAN, you need IP address. Okay, so a switch is used for the purpose of creating VLAN so that you can have different IP addresses, different segment of the network inside your own domain. Okay, so that is the power of VLAN. Yeah. So we did that last week. I showed you already, isn't it? Right? I show you how you create a VLAN using a multi-layer switch. We did a multi-layer switch to divide your network to different portions using a multi-layer switch. Okay, a multi-layer switch can actually your VLAN. We know that switch work on the layer 2. Layer 2 is the MAC address, isn't it? But when you have the different VLAN, different VLAN means different IP address, right? Different network of the IP address. With different network, you need a router. But instead of using a router, we use a multi-layer switch to simulate as a router for packet to move from VLAN to VLAN. So we did that last week. Okay. Now, the third point here, a command in the figure to the left. I'm going to explain this to you. Okay. Command in the left to the in the figure to the left should be used to configure IP address on the VLAN. Okay. Now, now this is a switch. You all recognize that this is a switch. This is also a switch. Okay. All right. Okay. You can see there's this is a switch. Now a switch to configure. Now a switch by default VLAN 1 is always on a switch by default. You don't have to do anything. The moment you get a switch, VLAN 1 is there. But other VLAN 2, 3, 4, 5, 6, until VLAN 4000, all these VLAN you need to create. Okay, we have seen it last week. Last week when we do the VLAN, we actually create VLAN 2, VLAN 3, right? But if I want VLAN 1, I actually don't have to create one. VLAN 1 is already inside the switch by default, so you don't need to create. So you can see from here, the first line here, I want you to look at the first line here. The first line here, they say interface VLAN 1. You notice that I don't even need to create VLAN. I just tell them that, oh, VLAN 1 is there. So I use the command interface VLAN 1. So you are telling them, okay, first of all, you must point to VLAN 1. Now, for a router, we can say interface port 1, port 2, G01, G02. Then you put in the IP address, right? Switch cannot use interface FA01, FA02. You cannot do that for a switch. Okay, you cannot do that for a switch, and then you try to put in an IP address into the switch. You want to put IP address in the switch, you must use the VLAN. So we are going to put a VLAN for the first line. You can see interface VLAN 1. After you have point to VLAN 1, you start to put the IP address already. You can see the second line. Second line here is maybe I change color to yellow. That you can see the second line here. Okay, IP address 192.168.10.2. So you put in the IP address. Just like a router, you need to issue a no shut now to turn on the port of the switch. Yeah. And then you can see after that you exit, right? After you exit. Now the switch, the router, just like, if you remember when you put in a PC, PC, you need to define what is the default gateway, isn't it? What is the IP address? What is the subnet? What is the default gateway, right? For a switch, also the same. You need to define what is the default gateway. But then how do you define a default gateway for a switch? The command to define a gateway for a switch is this. Under the configuration mode, you just type IP default gateway, and then you key in the router address. Default gateway is a router address. This is a router address, okay? Just like this address is put inside the PC, okay? For the PC, depending on your gateway if you are pointing for the gateway, because router got two port, right? So if you are pointing to the port, the gateway must be pointing to the port that is connected to the switch and the router. Okay, so this 192.168.10.1 is this one. You can see it's actually this one. The different switch will have different different gateway. So for this particular switch, the second switch S2 will have a different gateway. F2 gateway will be here, isn't it, right? So for the switch, S2 will have a different gateway for switch, which is in this case for S2. S2 will be for S2. Let's say if I ask you to configure S2. Okay, S2 will be IP default gateway for S2. Gateway. What is the IP address? The IP address will be 192.168.11.1. Okay, all right. So different, yeah. These two switches, you can see they are on different network, but one router but on different network. Okay, so if you have one is a .10 network, the other one is a .11 network, you need a router because they are on different network. Okay, so now you can see switch also need a default gateway, and the command is IP default gateway, and then you type in the IP address of the router port that is connected to the switch and the gateway. Okay. Question? I'll wait for you to ask question. Anyone? I mark attendance. Very interesting. Internet working is a very interesting subject. Okay, you can see how this thing works. Yeah, how packet move from point to point. How you configure the packet in the network. Okay, I mark attendance ready. Now continue. No question. Okay, this one is nothing. Okay. All right, configure basic router. In fact, I try not to do so much on this that you already know. Okay, let's look at the first one. Some of the address. Okay, like you enable secret class. We have done this already. Yeah, for router, we are looking at R1 now. Okay, enable secret class. The password to connect to your privilege. Your user executive privilege. For configuration, the moment you say enable secret, your password is a class. Your password will be encrypted inside the file. Okay, so it will be encrypted. It will be encrypted because you created this called secret. Okay, your line console is for you to connect. For you to connect, the first time you connect to your router, you need to create the line console. Okay, and for that purpose, for you to create a password. So the password in this case is password Cisco. We all know console. You must always turn on the console by using the your command called login, and then you exit. So done. This one done. So, but this password here is still not encrypted. I'll tell you how you encrypt it. To encrypt the password, you issue a command called service password encryption, which is here. Okay. Okay. Now, your password Cisco not encrypted. you must issue this command called service password encryption for your console password to be encrypted, or else you will not be encrypted. So by issuing this, everything will be encrypted. Okay, everything, including your class is already encrypted. So your password for your console right now will be encrypted because you issue this command called service password encryption. So the next one is the line VTY04. You can see this one. Line VTY04, this is for you to connect remotely. Okay, so 0 to 4 means actually 5 users. You can actually have 0 to 15, Okay, so you want 15, if you allow 15 users to connect in, then use 0 to 15. But if you want only 5, 0, 15, actually 16. So 0 to 4 is actually 5 users. So altogether, there are 5 lines, 0, 1, 2, 3, 4. The password is Cisco. The Cisco itself is not encrypted, but because you issue the service password encryption later on, so your password the Cisco password is also encrypted. So the password is Cisco, but it's encrypted inside there. How do you know whether it's encrypted or not? All you need to do is just go into your running configuration file. You remember there's a running show run, right? The moment you do a show run, you can see that your password is encrypted. And whether it is line console, as long as you're doing a line login, whether it is directly or whether it's remotely, you need to issue this command called login. Okay, notice that. So don't forget. They ask you in the exam, don't go and miss this out. Okay, you miss this out. They say, oh, maybe they test you. They purposely take one, give you a screen and say something is missing. What is missing? Login is missing. The moment you use a line console or line VT1, you need to issue this command called login. You don't issue this command login, your router is not activated for you to log in. Okay, the password is not activated. All right, whatever you do, you are always done in your change color. Whatever you do, it is always inside your running configuration.
Sir, we cannot see what's on your screen.
You cannot see the bottom of my screen now?
No, I cannot see what you're showing on your screen.
Where? Not, but can see or not? What do you mean cannot see? Where?
No, as in I can only see your initials on the meeting. Chris Wong, CW.
Oh, serious? The rest can see or not? The rest?
Yeah, we can see. We can see.
Okay, Sean, I want you to log in, log out again, please.
Yeah, I also cannot.
Okay, but you all keep quiet for so long. You all cannot see. Oh dear. Okay, I am going to unshare and share again. Where? You keep quiet for so long. For those who cannot see. Okay, I'm going to close unshare. Now you see all this already, right? I'm going to share again. Share screen again. Okay, can see now?
Yes.
Yes.
Okay, very good. But you guys keep quiet for so long, all of you. Okay. All right. Thanks, Sean. Very good, Sean. Don't know what happened also. All right. Okay. Now, whatever you do, your configuration here, whatever you do is inside your running config. You must always save it into the startup config so that when you switch off the router, the moment you switch on the router again, it will load back all your password that you created earlier. And the command is copy everything that is done. Shortcut is just copy run start will do that. Just shortcut. Because Cisco recognize at least 4 letters. Copy run start. Actually, no need. Some say that if you try copy RS also can. But there's a space here. Copy RS also work. And then copy run start, copy running configuration to starting configuration, shorter copy run start, even shorter copy RS also work. Yeah. Question? No? Move on. Okay. Configure IP4 interface. That we have done this already last week. So I'm going to just do a fast one. Okay, we have done this lab. We done this lab on Tuesday. I remember. Now, this is the first line here is the first line there is for you to configure your router port, right? You don't need to spell out everything lah. You remember, you just put it at internet interface G00 or 01 will do, right? That shortcut will do. No need to spell out the whole thing. So interface G00. Now description, the word description here, this one is a command for you to type in some of the things that you know you are using the interface G00, right? But you don't know what is it for, isn't it? So when you type description something, and then over here it says link to LAN 1, it's just to tell the user, whoever log in, and later on when you're using this router, you realize that, oh, actually this port is meant for you to link to LAN 1, LAN 2, and so on. Just a description, nothing on it. After that, you put in the IP address. For login, for a line console, you say no, you say login, right? But for a router, you say no shutdown. Okay, for IP address, IP address you say no shutdown. For line VTY, line console, you say login to activate the password, right? For IP addresses, to turn it on, you must issue no shutdown. So okay, yeah. So that's the first one. The second one we have done. Any other thing we have done? Okay, this one nothing. We've done this already, so I just move on again. Don't waste time. All this you've done it under Network Essential. This is just a new command under description. I know you have not done description in your Network Essential, so this one is a new command. Okay, move on. Okay, this is your configure host PC1. This lab, tomorrow we're going to have a lab, right? We're going to do IPv6 lab, okay? To configure host PC1, statically assign an IPv6 address. So how do we do it?
Isn't tomorrow a public holiday?
Oh, yeah, so sorry, man. Tomorrow is a public holiday. So sorry, okay. So we do it on Thursday. Thank you, Sean. Thank you. We are going to do it on Wednesday. Wednesday is your. No, Wednesday is what? Wednesday is it lab or theory? Anybody can remember? Lab, right? Wednesday is a lab, isn't it? Right? Let me check. Let me check whether lab or suddenly I forget. Just a moment, I'm checking. Okay, Wednesday is yeah. When we do lab on Wednesday. Yeah, okay, we do lab on Wednesday. Yeah. Okay, now IPv6 router interface. Now IPv6 is actually 128 bit. Okay, 128 bit means you all know how does V6 addressing is it? Anybody doesn't know V6 addressing? Anyone? IPv4 is 8. Every 8 bit, every octet is 8 bit, isn't it? 8, 16, 24, 32, right? Okay. Like for example, IPv4 is 192. Okay. 19. I'm trying to create different color. 192.168.0.1. Every octet is 8 bit, 8 bit, 16, 24, 32 bit, isn't it, right? IP address for IPv4 is 32 bit. That's why 32 bit addressing sooner or later is going to run out, no more. So that's why they use IPv6. IPv6 is different. This is an IPv6 addressing. For example, I'll give you one example, okay? 2001, every hectare, octet is for IPv4. IPv6 is called hectare, okay? 2001 colon 0db8 colon ACAD colon, for I'll just give you an example only okay. 0003. Okay, for IPv6 every octet is 16 bit. Okay, 16 bit. You know what? 1 times 16 is 16. 1 times 16 is 16. 2 times 16 32. 3 times 16 48. 4 times 16 64. You can see 64 bit. 64 bit for the network. No, this is just a network only. Okay. So if you are talking about where is the host? The host is actually another number. So another number could be something else. Okay. I just give you an example. It can be A A colon B B B B B colon C C C C colon D. You can see this is your host. So total this is 128 bit, 128 bit, because for your network you have 64 bit here, 8, 16, 32, 48, 64, right? So altogether there are 128 bit for IPv6 addressing. And for IPv4 only 32 bits only, Can you imagine, how many IP addresses you can create using 128 if you have 128 addressing? A lot, okay, a lot of IP addresses. That's why some company already started with IPv6 addressing. Some companies still using IPv4. Some people combine, using IPv4 and IPv6 addressing. So your router must be able to handle both. Both IPv4 and IPv6 addressing. So we have been doing on IPv4 all the time, right? So let us look at some of the IPv6 addressing. Do you know how they do IPv6 addressing? Maybe I just do some. Let me see. I want to. Yeah. I want to show you for your IPv6 addressing, if it's a 0 in front, normally we don't put. I don't know whether you know or not. Can you see this addressing that I put there? 200100DBA ACAD 003. If you want to make it shorter, as long as there's a 0, as long as there's a 0 in front, you don't actually need to put down. So if you want to rewrite this, I'm going to put it at the bottom. Okay, if I want to rewrite this on this addressing, it can have 2001. I'm writing below 2001:0 DB8, because 0 is in front, right? If it's a 0, you want to make it shorter, you don't have to write it DB8. Okay, so take out the 0. Colon ACAD, and then you can see the next one is 003, right? So the first one is a 0, second one is a 0, third one is 0. You can take them all to 0, right? So you can make it shorter by putting a 3, okay? As long as it is a 0, you don't need to put in any put the 0 in front. And if you want to make it shorter, it happen to be a 0. For example, if this is a 0, let's say for example if it's not a 0, 0, 0, 0. Let's say it's not ABCD or UDBA. Let's say if it's a 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. If you don't want to put, also can, Let's say for example, 1, 2, 3, 4. Let's say for example, it's a 0, 0, 0, 0, all 0, isn't it? You don't want to put, also can. You can take away all the 0, You can actually take away this 0. You can actually take away this 0. It becomes like that. It becomes 2001:::3, also can. Okay, so to rewrite this, let's say for example everything is a 0. Let's say if this is a 0, to make it shorter, you can actually put this now. Instead of putting all the 4 0, you can just put 1 0 will do. Also can to represent. So as long as it's a 0, you can make it shorter. Or you understand? Okay, as long as it's a 0, you can make it shorter. Yeah. So if this is the case, you can make it shorter by doing this. You can actually do this. Okay, let's say everything is a 0 in front. You can actually put it as let me put the drawing. You can make it as 2001. So if it's a 0, you don't need to put also can. You can just do like that. 003. 003. And you can take out all the 0. Use the 2 colon to represent the missing 0. Yeah. Okay. Yeah. So that's how you make it shorter. Yeah. If you still don't understand this, I will explain in one of the lessons. Show you how they can actually write IPv6 addressing. For those who don't understand, if not, don't waste time on this. I expect you to know already by now. Okay. Any question on IPv6? Anyone? Anyone IPv6? Don't know how IPv6 addressing? Okay now, y'all okay now? Okay, so I will take make it meter, take away this. Okay. Now, to configure host PC1, let's look at this right now. You can see statically assign IPv6 to the host under the IPv6 property. Okay, so if you are using IPv6, you can see that the I don't know what this if you are using IPv6 for PC, PC you all know can use IPv6, right? Okay, maybe I show you the IPv6 addressing. I cannot now because this one is sharing on the PowerPoint. Okay, for PC you can put in an IPv4 addressing or IPv6 addressing. Just you all know, isn't it, right? But in the lab you'll be doing IPv6, so you all can see for yourself later on. Most of the time we don't touch the IPv6, we don't care. Okay, we always say okay IPv4, so IPv6 we don't care. Actually we can put in the IPv6 addressing also. Okay, now that's the first thing. Configure, and that's the first one. Configure an IPv6 interface is very similar to when you're using an IPv4 addressing. It's actually the same. The only way of is the numbering is different only. Okay, if not, the way you put your IP address to the router or to the PC is exactly the same, but the numbering is just different. That's all. Third one, has shown the figure, configure the interface IPv6 and subnet mask. Okay, I'm going to show you, like in this case, okay, same thing. This is the same as just now the one, right? This one, isn't it? This is IPv4. This is IPv6. Okay, I'm going to make it bigger for you. Yeah. Now, for the first one, router one, I'm looking at router one right now. You can see I'm looking at router one. So everybody look at router one. Right, the first line. Interface interface S000. You don't have to say serial S0. Just shortcut S0/0/0. Okay, so you are configuring an interface at this port. You're configuring this port. Okay. Description, same thing. The description is just to tell anybody who use this router later on is tell that person what is this interface for. Now you can see that I want you to look at this IPv6. Now you can see that when you're using IPv6, you must say IPv6 address. Okay, can you see the V6 there? If you don't key in the V6, the router think that you're keying the IPv4 addressing, and they will hit error when you key in the IP address of using the IPv6 addressing method, so they'll hit error. But in order to prevent that, you must say IPv6 addressing. IPv4, you can see there's no IPv4, right? You can see the addressing is IP address. By default, this is IPv4, yeah? But when you're using IPv6, you must tell them IPv6. You must tell them. You don't tell them, they don't understand. So, okay, the addressing is, now, I want you to look at this very carefully. You can see this is the IPv6 addressing. This is what I'm going to put in, okay? This is what I am going to put in. Okay. Now the address is 2001. Start from here. 2001 DB8. Actually, there's no zero in front, isn't it? 0 DB8. I take away the zero, right? Because as long as the zero in front, you can take away. ACAD. You can see 3. Now 3 point to the network. Just let you know. 3, this is the network, okay, because the first 4 hectares always refer to the network, because altogether there are 8, right? The first 4, 1, 2, 3, 4 belongs to the network, the next 4 belongs to the host. And then you can see that the 2:::::1 :::1 means the port here is actually the host given to the port. The host number given to the port is 1. So this is actually 0, 0, 0, 1. But because it's all 0, that's why you have : : represent everything 0. Okay. So the 1 refers to the port 1 here at this stage 1. Okay. How? All right. Okay. Are we doing the S00? Yeah, refers to the port 1 here. So far, okay? Question? Now the 64, now remember in your IPv6, you must tell them what is your subnet mask, isn't it? IPv4 is 255.255.255.0, right? But in IPv6, there's no 255, right? IPv6, the first octet, the first the zero here show you this is network, right? This show the 255.255.255 show you the network. So for your IPv6 where is the network? The oblique 64 this part show you the network. So your first four number first four hectare is your network. 2001 dba ACAD colon and 3 is your network. Why? How do you know? Because 64 point shows you that the first four hectare is a network. It's just like in the IPv4, they say 255.255.255, right? 255 shows the network, isn't it? So for IPv6, that number there shows you where is the network. So in this case, the network ends at 64. Okay, so this is the network. This is a network. Okay, this is your network. Network stop until here. Okay, your network. Your one is the host. Okay, your one is the host. Now you can see there's a clock rate 128, right? 128 kilobits per second. And the 128 shows you this is this. You are configuring your router here. This router. When you put in 128,000 bits per second, this is become the DCE, isn't it? Right? This is the communication part. It is just like for a router. You know, I told you like when you have a two router communicating each other, it is just like one is ISP, one is one is you lah. You know, your ISP router to your router, right? So your router is the one that is always the DCE. They are the one who is giving you the speed, okay, the clock rate of the speed. It's, you know, sometimes when you subscribe to when you subscribe to internet, you say 1 gigabits per second or 500 megabit per second. You subscribe to that particular rate, isn't it? Right? Same thing here. Now this is like your router. So when the router, this router is like your ISP. ISP connect to you. So when the ISP connect to you, depending on your plan, you know, your internet plan. If you are buying 1 gigabits per second plan, then the clock rate will be different now. You know, just like they'll set a different clock rate for you. But if you're buying 500 megabits per second, then the clock rate will be different now. Yeah, right. Okay. So the clock rate is actually the one very likely from the ISP that they will set depending on what kind of plan that you buy from them. Yeah. So. But for a Cisco router, for your information, if you don't do any clock rate, by default they'll give you 2 megabits per second. Okay, by default it's actually 2 million 2 meg. No, there are 2,000,060 plus 2. So by default it is 2 megabit per second. But if you want it to set on your own, then you use a clock rate command. Clock rate 128 bits per second. For information, this one let's say for example during the PA, if my PA asks you to do a clock rate, you must do this, okay? But in the lab itself, if you don't do it, also can, because by default they will set for you 2 megabits per second, okay? So after you set the same thing, just like IPv4, you must issue a no shutdown, same thing, yeah, okay? So maybe you look at this diagram here. Maybe it's good to you observe this diagram for a little while before we move on. Okay, I will just erase all these things first. Wait, okay, make it neater. I want you to look at the IP address of you. Okay, look at the IP address very carefully. The first one, for the first IP address is 201. This is a network, right? Network, isn't it? 201.0DBA/ACAD3. Now you can see this is a 3. This is a network. This is a 1. Do you notice that? Another network, right? This is another network. This is a 2. So you can see the network is different by the last number only, you know. But you can create a lot of network because the whole thing can be a network, isn't it? But they changed the network by changing the fourth hectare of the IPv6. They changed the fourth hectare. This is 1, this is 2, and this is 3. Do you notice that? Yeah. So you can see behind there's no number, no. Why? Because this is a network. So network it is just like 192.168.8.00. The network, they don't show you the whole number, isn't it? So over here there's no whole number because they're just showing you the network only. So this point this will be of So this point will be 2001.0db8 ACAD 1 ::1. This is the same thing. Repeat. This one is at 201.0db8 ACAD 2 ::1. This one also 1. Okay, but the network is different. Okay, this one for the S000 is a 2001 db8 ACAD 3 ::. Actually, this one, can you see the 225 here? 225 here means 225. Okay, so 225, this is 226. Yeah, okay. So this is a host number. But this one, apparently they put 225 here, but they put the one here different. So not a very good example. Okay, all right. They configure as IPv6 201 db8 :3 :1. Yet they put a 225 here, so not a good example. This one should be 225. It should be 225. Okay, all right. This number here. Okay. Question? Anybody? Any question? Any question? I erase. Yeah. Move on. Move on. Okay. There are a few things here. Unlike IPv4, IPv6 interface will typically have more than one IPv6 addressing. Yeah. Typically more than one. Why? Well, because there are three. There are three. The router you can see there are three. Yeah. Highlight the router here. You can see there's one here, two here, 3 port. Okay. An IPv6 device must have IPv6 link local address. Now, you see this link. This is, look at this sentence here. What is this link local address? Now, your IPv6 device must have an IPv6 link local address, but will mostly likely also have an IPv6 global unicast address. For your information, if you are using then IPv6 addressing, whether you're talking about a PC, whether you're talking about a router, both of them, a PC or router, will have two addressing in one port. In one port there are two addressing. One is an IPv6 address. One is what we call a link local address. Okay, all right. We'll touch on the link local address in our lab on Wednesday. We will touch on the link local address. Okay, link local address is very unique. IPv4 got no such thing as called link local address, right? IPv6 got an extra address called the link local address. For example, I give you one example. Okay, a link local address is actually very interesting. Let's say, for example, I got a PC. Okay, I connect these two PC together. If I connect these two PCs together, if I'm using IPv4, okay, you need to key in the IPv6 IPv4 addressing. IPv4 here, IPv4 here. Then you can ping, isn't it? Right? Then you can ping each other. Okay. If you don't put in the IPv4 address, you try to ping each other, it will not work. But if I'm using IPv6 addressing, okay, let's say I change to IPv6. I change the addressing to IPv6. Yeah. If I'm using IPv6 addressing, actually I don't need to key in any IP address. The reason is if you are using IPv6 addressing, there's an extra addressing is already inside, created for you automatically. And that address is called link local address, link local. Okay, link local here also. I can actually ping because I told you, right, link local address is automatically created. If you are using IPv6, that is created for you. I can actually ping the two address each other, and they will talk to each other. With the link local address, they can talk to each other. I don't need any IPv6 addressing. Okay, IPv6, if you are using IPv6 address, there's an extra address inside there called the link local address, which they can communicate each other. Okay, that's why they talk about this link local address here. Every port there is a link local address. Okay, even for PC also. We'll do it on Wednesday. An interface can also have a multiple IPv6 global unicast address from the same subnet, so you can actually create a lot of IPv6 addressing. Yes, just IPv4, same thing. This command can be used to create a global unicast or link local address. Okay, so there's something that you need to see here. Okay, Right. We are going to do this next Wednesday. You know, your IPv6 addressing, we are going to use what we call an EUI-64. Okay, we're going to use this as now. This EUI-64 is actually one of the command for IPv6 to let them create an IPv6 address for you automatically, so you don't have to do anything. So the moment you type EUI-64, they will create a host address for you. They will even name it, just like in our IPv4 we use DHCP, right? The DHCP will create the IP address and then give it to the PC, isn't it? But for IPv4, if you use the EUI-64, they will automatically create an address for you. You don't have to do anything. Okay, you don't have to name what is a host address. You don't have to. You just type this only and they'll create for you. So we're going to do this on Wednesday, just to touch on this a little bit here, okay? All right. The link local address also. I told you link local address for every PC and a router is automatic. It's actually automatically created even for a router. But if you want to create your own link local address, also can you use a command here, same thing, okay? IPv addressing, and then you type in something, tell them that, oh, this is a link local address. Then they'll know that this is a link local address. If you type EUI-64 in your addressing your router, you are telling them, okay, create an IP address for me, okay? They will create an IP address for you. Using the network that you created plus the host number, they will give you a host number, okay? And we're going to touch this on Wednesday, yeah? Okay, let us see now. So how do you do IPv6? Same thing, you can see from here, same thing. First thing, you define the interface, okay? You define the interface of which interface you are to do. Okay, I'm going to do interface S000, and then I'm going to put in a description. The description, nothing like just to tell the user what is this port for. And then after that, you start IPv6. You key the IPv6 addressing. Okay, can you see they use a 1? Actually, they should not use 1. They should be using 225. 225. Why? Because the example use 225 here. Okay, so they should not be using 1. But if you use 1 here, then it should be 1 Then this should be 1. It should be 1 Okay. All right. The clock rate is there, just like IPv4. You need to issue no shutdown. Right? Question. Any question? No? Okay, now come back to IPv4 loopback. Okay, IPv4 you all like, I know, but actually IPv6 more interesting. Now IPv4 loopback address is typically configured on a router for testing management purpose. I told you, right? When you are putting a loopback address on your, that day we put a loopback address here, right? Remember we put here L0, L00, L01. Remember we did this lab, we put in the 2 loopback addresses. So what is it for? IPv4 loopback interface is typically configured on a router for testing and management purpose. You remember I told you, right? One of the reasons you want to put in the loopback address is because sometimes you want to test whether the router is working. Everything is off, okay? But your router is off but not connected to the internet, so you don't know whether your router is working or not. You can actually ping to the loopback, then the loopback address, when you receive a reply from the loopback address, you know that the router is working, yeah? A loopback interface is a logical interface internal to the router. It's actually meant for you to do testing. It is not assigned to a physical port, but it is connected to other device, okay? So you don't assign to a port number, okay? But you assign to a logical number called loopback 0. Like for example, in this case, you see, you can see that, okay, can you see loopback 0? Instead of interface S000, you say interface loopback 0. So you can put interface loopback 0, interface loopback 1, interface loopback 2. Okay, so this is just the logical number. There's no port number. Okay? It's for you to assign to a logical number so that you can virtual number so that you can do testing. It is not assigned to any physical port, like it says here. It is a software interface that is automatically placed in the up state as long as the router is turned on but not connected to the internet. The word functioning here means as long as it is connected, it is turned on. you test on the loopback of the router, you know whether a router is working or not. So sometimes you want to do this because it is not connected to the internet, so you don't know, so you want to test the router. So same thing, you want to put in the address on the loopback, you put interface loopback 0, then you put in the IP address of the loopback, and then you exit. You don't need to issue shutdown. Notice that loopback address, the moment you say interface loopback 0, you can see that the line will turn on automatically by itself. You don't need to do a no shut, loopback no need. Okay, this is just your info. Some routing protocols such as OSPF require address for the identification. The loopback address can be used rather than interface. Okay, I mean the loopback address I told you is meant for you to test on the router, right? Not only that, for your OSPF, you require this loopback address. It can be used rather than an interface address, which might go down on occasion. So when you use OSPF, you are using it just for it to run OSPF lah. Okay, if you remember, this OSPF is just one of the shortest path. I remember the shortest path. This is one of the dynamic protocol. Dynamic protocol for you to connect. If you want to assign your network instead of saying a static route. Remember that I told you we done the static route already, right? So your dynamic route, we use one of the way to use dynamic route is use OSPF. You can use RIP, OSPF, and then the one is EIGRP, right? But for OSPF or EIGRP, we are not going to do on the lab. We're going to do on the lab using RIP. Your PA will also be using RIP, okay, the dynamic routing, okay? So OSPF require some routing protocols such as OSPF require an address for identification. The loopback address can be used rather than an interface address, which might go down. Okay, OSPF, just in case you want to test OSPF whether the path is working or not, you can actually use a loopback, using a loopback to test the path whether OSPF protocol is working or not. So this is just meant for testing. Useful for testing when you're running OSPF, okay, when you're creating a loopback. Useful when you're running dynamic protocol using OSPF, okay, right? If not, if you're not running OSPF protocol, then you use the loopback just for testing the router itself, like to see whether the routing is working or not. Yeah. Okay, lab, yeah, finish. All right.